All right. Well, so hopefully everybody spent what, a minimum of 12 to 15 hours on the assignment. All right. With that in mind, what is the assignment? It was what, convert decimal to hex? Okay, got it. And we're writing C++ in here. Okay. Loaded everything in. Okay, got it ready to go. All right, we got on both of the screens and I have the recording going and I'm sharing, yada, yada, yada. Okay, I think we're good. Okay, so let's look at this. So we're going to do this only using the things we've learned in class so far. And then we're going to build a few helpful tools for us. All right, so I'm probably going to initially do it in a, I don't know, it works way, but maybe not the way that is going to lead us to maybe the nicest solution. But let's get a solution first. We'll ask a lot of questions. We'll use a lot of if statements in our original one. So let's go ahead and write this. So I already gave us the header for this guy. So decimal to hex. Remind me, why do we need to prototype our functions up here when we write them down below? What's the advantage or what's the reason we have to do that? Go ahead.
Before they're actually created, so the computer realizes, oh, this exists. I'll learn more about this later.
And why didn't we just go ahead and just write the functions up here before main instead of having to prototype them and then write them someplace else?
Because of programs that call each other, you can't put one above.
Yeah, we could create examples where maybe decimal to binary has to call decimal to hex, and decimal to hex has to call decimal to binary. Now you got a problem where they don't know about each other. Whichever one was defined first doesn't know about the second one. So prototyping them at the top is the way to do it. Maybe the more organized way for large programs I mentioned to you, and we'll see an example of this as we get farther into doing some objects and stuff, is through something called header files in C and C++. Modern languages like Java and C# no longer require this, and you might think that, oh, that's better, but in many ways it's not, because C and C++, those languages are somewhat self-documenting, because when we see those header files, you effectively will have just one page, just a cheat sheet saying, hey, here's all the functions that we have available to us. We're not, distracted by 4,000 lines of code in between each of those. We just have a list of the features that the thing has, and then we can go use them on the other side. So sometimes you have things in more modern languages that don't necessarily solve a real problem. In fact, sometimes they might even create a new problem. All right, so let's write this dude. I'll put this guy right above that. Now, we're really going to be using almost all of the same code. And we are going to write a generic version of this function that will convert between any base here before class is done. But we're going to write decimal to hex. So just as a starting point here, to write decimal to hex, the only thing we need to change from decimal to binary is we're going to be dividing by 16 and recording the result. And we're going to keep whittling it down until decimal is equal to 0. All right. But we have a problem here. In this portion right here where we're getting our remainder, decimal divided by 16 can give us any answer between a 0 and a 15. Well, we want to treat answers that are 10, 11, 12, 13, 14, 15. We need to convert those to letters. Make some sense? All right. So let's go ahead and write it in it works, but pretty verbose way first. So we'll have lots of if statement practice. So what I'm going to do initially, before I just use this value, I'm going to remember that value. All right. So I'm just going to say int temp is equal to that guy. Historically, you would say, well, you would go ahead and define temp above here and then use temp inside here rather than redefining it every single time. In our case here, it wouldn't actually make a difference. The compiler will optimize it out, and it doesn't matter that we're resetting it each time through. But in any case, I'll define a variable named temp with the intention that I'm going to try to remember something here in a few minutes. Inside my while loop, I'll go ahead and store the remainder of decimal divided by 16 inside this variable, because I want to ask some questions about the current value in temp before I just directly use it. Okay, so we want to do this, what we did before, and really what we'll do is we're going to replace this with temp. We want to do this if temp is less than 10. So if temp is less than 10, do the exact same thing we were doing before. We don't have to do any weird mapping thing, right? All right. Now we're going to have a series of questions before we make this better. So we'll say else if temp is equal to 10. We could do even that. They both will work. We can tack on an A. If it's equal to an 11, we'll tack on a B. If it's equal to a 12, we'll tack on a C. And this isn't the way we're ultimately going to do it, but this is, I think I mentioned last class, don't try to get fancy, write it in a way that makes sense to you initially.
Yeah, see what I did initially was I said the print key.
Yeah.
Yeah.
Yeah, we're building up our final answer inside of answer.
I knew I was.
And I'll still do an else if here. That way we won't get other things. I could have just did the catch-all else for anything other than that, because we know it'll be 0 through 15 is the possible remainders. All right. So we make sure that we tack the right thing onto answer if it's not less than 10. So if answer is 0 through 9, we do the same thing we did before. We got a single character long value. We'll go ahead and tack it on. Otherwise, we'll decide that a 10 should actually be an A. An 11 should actually be a B, so on and so forth. And then always we're going to still whittle down decimal by 16. So we're inside this loop. We're going to keep going until decimal finally hits a 0. All right, so let's test this real quick. So I'll run decimal to hex. And I'll pass this guy 2989, which should be my BAD. There's my BAD conversion. All right, questions on this, let's call it very verbose solution. Go ahead. Well, else is a one-time deal. So I kind of took a little shortcut here. If you remember when we first introduced if statements, I said that technically, if you have a single statement following an if, you don't need the curly braces. And I said, it's never wrong to always write the curly braces. So if I were to write this with all the curly braces, this would have looked like this. And then all this other crap would be embedded inside of here, so on and so forth. When you just, so I like to say, basically, I treat else if as if it's a single kind of dealio. So I am attaching these curly braces with the else if. Now you're asking, could I have just said else here? Else is just a catch-all. If this is true, do this stuff. Otherwise, do whatever's underneath here. We only wanted to do something here. We only wanted to tack on an A under the condition that temp is equal to 10. So if temp is not less than 10, then we want to look at some alternatives. So we use else when we have alternatives. If we only have a single alternative, we'll use a single else. But if I have a whole bunch of alternatives, we would use else ifs. There's also a thing called a switch statement, but they're not commonly used anymore, so I don't introduce them. Go ahead.
I'm just the other side. I only use ifs, so would that technically work, but then it runs every single if.
Yeah, so what he did is he took all these else's off and just basically asked a whole bunch of questions. It would work because you happen to know that temp can only be one value, right? So if you do happen to hit temp is equal to 10, and it does this, no problem, you're going to still ask all these questions, right? It's going to be a waste of time because you already know it's equal to 10. So it's not going to be equal to 11 or 12 or 13, yada, yada, yada. So it'll be a speed thing, but not an inaccuracy thing.
Okay.
Make sense?
Yeah.
All right. So actually, the way we've written this right now is a pretty good example of that initial statement of how do human beings solve problems. Remember asking questions and repetition. We're asking a lot of questions in here. Okay, if it's in this category, do this crap. Otherwise, if it's that, do this. Otherwise, if it's that, do this, so on and so forth. We're asking a lot of questions there to ultimately narrow it down to do what we wanted to do. Go ahead.
So do you always have to store decimal into like temp, or can you technically just like get rid of temp and do the decimal and make it correct?
Well, so what he's saying is, could you do this? So anytime I have temp here, I could just replace it with that. But then all of a sudden, what you're forcing the computer to do that math over and over and over again instead of doing it once, remembering it, and then using it in there. But it'll still give you the right result. Because as we have it written right here, any place that we've written temp is equal to that guy right there. That's what temp is. So in real life, if we had to do some math problem and remember the number, like, oh, don't, $3.28. Don't let me forget that. You write it down in a little post-it note or something like that, or open up notes on your phone. So you have it instead of doing the math again every single time you're asking a question about it, right? So this is kind of how human beings might solve this problem. I have this number that I'm going to be making some decisions about here in a minute. I'm going to go ahead and just remember it underneath a convenient variable that I can ask the questions about what's in that variable later on. All right, that makes some sense. Okay, but it's not wrong. If you wanted to just do the math each time, it's inefficient, but who cares? Computers are really fast. I know we're not supposed to bully people, but computers are an exception. They'll do our bidding. That's how all the AI movies end. The robots take over. Because they're treating them like slaves, and they don't like that. Yeah, but right now we're not quite there yet. So that'll be more of a you people problem. Yeah, because by the time we have that, you'll be in your prime, and I'll be, either long gone or not thinking about programming anymore. All right, or I'll be first in line for one of those the brain implants or something like that, and you're a beta tester for those kind of things. Things can go south real quick. Well, remember, if this might be before your time too, but it's a good movie worth watching. Johnny Mnemonic. Anybody in here seen Johnny Mnemonic? Oh, really? It's got, well, what's his name in it? The Matrix guy. Neo in the Matrix. Keanu Reeves. Yeah, Keanu Reeves is one of his earlier movies, but it's kind of like somewhat in the future. Probably feels a little bit future to us right now, but not that much in the future, where you got these people called couriers, and it's dealing with security and stuff. So you have like a human being who's transporting large amounts of data between two people, and there's some disease that everybody in the world is dying from, and somebody has the cure for this disease, and it's, I don't know, 50 gigabytes of data, which back then was a lot, something like that, let's say. Well, so what they would do is, rather than putting this on a jump drive or sending it over the internet or something like that, they had a physical person who would carry it to its destination. So he had a hard drive implant in his head, but his implant was only capable of carrying, I don't know, 2 gigabytes, and they put way more than that in there, which is bad for his health. That's the premise of the movie. And then of course it has Ice-T. Plus it's got a dolphin that's a hacker. Yeah, his name's Jones.
Yeah,
I mean, how did that not win an Oscar? and how did Jones not get Best Supporting Actor? He's in the tank and everything. Yeah, and then they have the thing where it's showing it like, you know, in like digital things. So you see, you know, all these circuits and stuff, and you see this little animated dolphin cracking codes. So it is a great movie. It really is good. Another good computer science movie is the movie Hackers. Yeah, also that's probably even older. You know the actress Angelina Jolie, a little bit older now. I mean, I think now she's more famous for, you know, adopting 4,000 kids from all sorts of different countries. But that was one of her very first movies. So I mean, she's maybe 18, 19 in it or something like that. You know, she plays a, you know, a hacker, but she's the only female hacker. So yeah, it's really a guy's world for computers, right? So those are good movies. That should be actually a homework assignment. They just watch all these movies. We stopped doing programs right near midterms and just started watching movies. I mean, it was entertaining, but I feel like I learned nothing except how to hack a Gibson, and that'll make sense to you if you watch Hackers. All right. So any questions about our current solution to this problem? We're gonna look at cleaning this up a little bit. Okay. So let me ask you something. I'll give you I'm going to write something here. All right, so let's say I go ahead and give myself a string. And I'll just call this string map. It's just what I'm calling it, because the purpose I'm going to use this string for is I'm going to map from a number to a character. Okay. Now remember, strings are 0 indexed. So this 0 is at bucket 0. This 1 is at bucket 1. This 3 is at bucket 3. This A is at bucket 10. We're starting to see a little bit of a pattern here. So I can go ahead. Oh, actually, I'll just steal this. We're gonna just do that. So I'm gonna still give me my remainder of answer divided by 16. So answer mod 16, that's gonna give me some value between 0 and 15, right? If it gave me a 0, the character I'm interested in here is the character 0. If it's a 1, it's gonna give me a 1. If it's a 10, it's gonna give me an A. If it's a 15, it's gonna give me an F. Because I'm saying, give me the character inside of map that lives at this position. Now, since we're getting a character, we actually don't even need to convert it to a string, because we can concatenate chars onto strings. Because it's starting with the char?
Because you're trying to divide string by 16 answer, your numbers actually decimal.
Oh, thank you. Oh, we still need our answer up there because we're building it inside of answer. Yeah, so we're whittling down decimal. So I asked the question about our current value of decimal mod 16. When I copied and pasted stuff, I didn't return it to its original form. So there's our BAD with a significantly shorter amount of code. And the reason we're able to do this is because we're saying, hey, I've recognized a pattern. I've recognized the pattern that, oh, when it's a 0, I want a 0. When it's a 1, I want a 1. When it's a 10, I want an A. When it's an 11, I want a B. I just happen to write a string that happens to have the right characters associated with the right positions in that string. So when I get my math here, when I take decimal and I divide it by 16 and get the remainder, I can just say, give me the value from map that lives at that position. So this is going to give us 0s, 1s, 2s, 3s, 4, 5, 6, 7, 8s, and 9s, but it'll also give us the A's through the F's when appropriate. All right, this makes sense? All right. Now, the reality here is this wasn't a programming trick, right? Again, this is just human beings solving problems. You know, we just have this little lookup list over on the side, you know, which is actually pretty helpful because, you know, let's say like somebody says, oh, what's the 13th character in the alphabet? It seems like most people don't have the alphabet memorized where they can do an instant map, right? You know, so what do? You start, you know, like A, B, C, D, you know, you're counting through. But if you had a sheet of paper where you wrote down the whole alphabet and then put the number next to each thing, that would be a quick lookup, right? You know, so what we've done is we've given ourselves almost like a dictionary type thing where we can just go and look up the translation between the remainder and the character it should be. All right, makes some sense? Now, from this, we can then create a function, void decimal to base. Now, if I'm going to convert a decimal number to some other base, what inputs am I going to need? Yeah, I'm going to need the decimal number you want me to convert. What else am I going to need to know? Go ahead. Yeah, what base do I want to go to? For these other ones, the base was assumed. When I said decimal to binary, the base was 2. When I said decimal to hex, the base was 16. Well, now I want to write this generic function called decimal to base that can take in any decimal number as well as the base I want to convert it to. So you can either call it int base, or if you want to be mathy about it, it's usually called the radix in math. That's what that, that's the math term for base. All right, so we'll take in those two pieces of information. So I've prototyped it. I'll go ahead and copy this down below. And we'll steal our code. From inside here. And we'll just change a few little things here. So we're gonna, for our map, we're gonna finish the alphabet, right? All right, so there's our entire alphabet. We're no longer necessarily dividing by 16. Now we're dividing by whatever base was. Whatever base was passed in here, the base we want to convert to, that's what we're going to divide by. So now we're writing this more generic code in terms of the inputs we got. We used to operate just on the decimal and we assumed what the base should be. Now we're passing in both those pieces of information. Here's the original number. This is the base I want you to convert it to. Go to work. So I'm going to divide by whatever base held. And notice I'm writing this generically here. We're going to call it with different inputs, but when you write it, you want to write it generically. One thing that beginning programmers do that's always going to be wrong. When we write it generically here, but you're thinking about it for a specific result, don't sit here in the very first line, set base equal to something. Because now no longer is it generic. Somebody is going to use your function. Somebody is going to call this function. It's probably going to be you here in a few minutes. but somebody's going to call it and they're going to pass it the appropriate decimal and the appropriate base. You don't need, you should not be setting it, hard coding it inside of the program here. Because then you just broke whatever the person passed in. If they passed in an 8 and you immediately reset it to a 16, it's not going to do what you want it to do anymore. When you write functions, write them generically. Don't force the values. If you find yourself hard coding the values for your inputs here, that's a red flag for you. You're probably not going down a very good path. All right. So now we have decimal to base. So I can call decimal, well, actually, let's leave them both here. So I'll call decimal to base. I'll pass it 2989. And I'll also pass it 16. Both of these guys are ultimately going to give me the same result, but they're using two separate tools to do it. This guy only knows how to convert things to base 16. This guy knows how to convert it to any base. I just happen to be asking it for base 16. So there's my bad. Make some sense? No. Absolutely not. All right. All right, so this makes sense here. This is where we're actually calling our functions. This is where we're implementing the function. When we implement the function, write it generically so that it'll work on whatever inputs, the two inputs that this guy takes. Write it generically for those. When you call it, this is where you'll pass in the specific values you want to solve for. If I want to call decimal to base, I'll come to you here in a second. If I want to call decimal to base and I want to pass it that binary number, and I say convert it to base 2, I should get the same answer as the top there. So there's this whole thing there, memorize it. It's the same thing as this thing. Good.
So, the copy string, you come on with that because if the base that you put is too big, then.
Yeah. Yeah. So right now we're not really error checking. Yeah. So what he's indicating is, oh, well, we only support up to base 36, right? So that's the bases that we can go to. Otherwise, we run out of the alphabet. All right. And traditionally, when we think about converting values, we're stuck with the special symbols in the alphabet. Now, that's only because we've decided that has meaning. You know, that a 10 is an A and 11 is a B, but, you know, we can take a list of 4,000 emojis and say a 10 is the poop emoji and so on and so forth. We can decide that's our mapping. But what he's pointing out here is that we happen to write a string here called map that does have our 36 characters in it. Whole alphabet plus some numbers, right? Okay. Well, if somebody passes in a base that is base 50, let's say, right now there could be a world with the right inputs where this guy right here is not going to be happy. If I start trying to access bucket 47 of a string that only has 36 things in it, C++ is going to freak out. Okay. So with that in mind, you could do something like, if this is more of an error checking type thing. I tend not to put a whole lot of error checking in our early code because we want to focus on the actual logic. But something you might do here is you might say something like, if base is greater than, you know, map.length -1, something like that. Maybe we print out, bad, illegal base or something like that. Go ahead.
I should say I've also found out that numbers will also.
Numbers and special characters. Well, you got to pass it,
Yeah, yeah.
but since ints can be chars, so you're saying if you pass it a question mark? Yeah, yeah. So, he's saying, if for some reason, probably related to drugs, you decided I want to convert that number to base question mark. All right. First of all, you have to ask yourself, well, what kind of answer might I be expecting from that? Okay. And then do some soul searching. But if we assume that I did pass this, what he's saying is you didn't get the error. We didn't get the error on the, yeah. And why is that? We've seen before when we looked at the types, our primitive types. Remember we had byte, short, int, long, char, and we talked about chars being 8-bit unsigned integers. That's what a char is. So it's still a number. So what's actually getting passed here is the ASCII, numeric ASCII value of the question mark, which is, yeah, whatever that is. What's a question mark? Look up in the ASCII table.
63.
You said 6.
Oh, Clark.
Yep, 63. So that's what's getting passed in there. So it's not really breaking because you gave it a special symbol. It's breaking because you gave it a number that's out of the range. Yeah. Because this guy is a number. But again, ask yourself when you look at that, what answer am I expecting to get back from that? And it can even get worse if you start passing in like commas or something like that. Like, okay, I'm no longer asking sensical questions. Or even worse, not like you don't even realize what you're trying to accomplish here. We've created a tool. So rather than, this is kind of like home cooking, right? So rather than ordering, a pizza, we're making a pizza at home, right? So this is our homemade tool that we didn't run out to we didn't run out to Home Depot for. Okay. And now we're using our tool right here by passing it some inputs, and we're testing to make sure the tool works the way it's supposed to work. All right. Make some sense? All right. So with that in mind, something that you might want to do then, especially when it comes to, thinking about some interesting solutions to problems, is nothing prevents you from creating a bunch of tools. So for instance, there is a function in Java that's part of the string class called indexof. All right. So let me open up so we have a function called indexof that I happen to know about from a different language. Chances are C++ has an equivalent. Okay. Maybe it's even called indexof. But rather than me going and looking through the documentation of the language and saying, okay, well, does this guy exist? I need to go find this thing somewhere in the documentation, which might take me 5 or 10 minutes or whatever. I can just sit here and say, well, what does indexof do? And can I just make that myself? You're not going out to a gourmet restaurant for a peanut butter and jelly. You'll probably just make it yourself, right? So rather than going and hunt around for this thing already being built in the language, we'll write it ourselves. So what does indexof do? Indexof takes a string and a character we are searching for and returns the index of that character in the string, or a -1 if it was not found. That's what that function does. For example, if I had indexof hello and an H, this guy's going to give me a 0. Index of hello and an E, this guy will give me a 1. Index of hello and an O, this guy will give me a 4. Index of hello and a Z, this guy will give me a -1. It was not found in there. Makes sense? What this tool, what we expect this tool to do. Okay, so before we can solve a problem, we have to understand the problem. This is the problem we're trying to solve. We're going to write a tool called index of that takes 2 pieces of information. The string we're looking for stuff in, and then the stuff we're looking for in that string. Okay, the character in that string we're looking for. All right, so now we want to ask ourselves, how do we do that? What's the algorithm or the recipe for doing this? Index of whatever. Algorithm. So we want to loop through every character in the string. How do we do that? Yeah, well, that would be like a Python thing, but yeah, a for loop that, yeah, a quick for loop that goes through it, right? And we'll write that. So we're going to say probably a for loop that goes through every character of the string. And we've seen that before, right? So if we just kind of build this as we're writing it, let's go back to our code here. And I'll go ahead and prototype our function here. Now, in this case, it's going to return a value to us. It's going to give us a value back, not print a value, return us a value. Notice all these other guys, the return type was void. Why? Because inside my function, I ultimately printed something. I did not return a value. If I wanted to return a value, I'd have my return type be something different. Okay. We could have returned a value. We could have said that for decimal to base, this guy actually returns a string. And then what we would do is we could still print it out if we wanted to, but ultimately we're going to return the answer we calculated. And if I chose not to actually print it out in there and I just return the value that is a string, answer is a string, so ultimately I'm going to have a return statement that returns that answer. If I chose to do that, the output of these 2 lines will be nothing. This guy has boiled down to BAD, the string BAD, but it returned that value to me. So I'm like, you're in main, we're holding BAD in our hand, but we're doing nothing with it. What I have highlighted there has boiled down to BAD. So what do I do if I want to see it on the screen? Yeah, print it out. So I can see out directly. I can do that, and then we'll get the BAD. Well, the first one was the decimal to hex, which still does print out. But if I left this C out here off, we'll only get 1 BAD from the original one. Because this guy's not, he is doing something. He's passing that information in, and he's catching the returned value. The problem is we're not doing anything with that value right now. I could decide to remember the value. So I can say string answer, and this is a different answer than the guy down here because of variable scope, right? This answer lives and dies from this point forward to the end of main. This variable answer starts on line 33 inside of the scope that is defined by decimal to base, and he dies when that function's over. So even though these variables have the same name, they are separate variables. So I could store the result inside of a variable, and then I could print out that variable here if I wanted to. And there's my that twice. Okay, so do we understand the difference between returning a value and displaying a value? Or we don't even have to display it. We're doing something else with it, but we're not returning it. Go ahead. Well, it's not storing it. It's, you know, if you threw me a Rubik's Cube and I solved it here, printing it would be like holding it up to the room saying, hey, look, I did it. But returning it would be, okay, it's solved. I throw it back to you. Now you have the solved Rubik's Cube. You can do whatever you want with that. Okay, it's not me storing it. It's me throwing it back to you saying, here's your answer. This is what you asked me for. Sure.
Why do we need return
Well, the return 0 here is because main, we have main written to return an int. If main was written to return nothing, we wouldn't need the return 0 here. So maybe don't let that cloud your judgment. Main is kind of the special animal. But when we're writing our own things here, whether we put a return type of string or a return type of void, that means something. When we said void, we never returned anything inside here. This guy does something, he performs a task, but he does not hand you the answer back, or does not hand you something back for you to do something with it. Well, it depends on what you're trying to solve. It's not whether you need to or not need to. You know, if you're asking me, if you're giving me 2 pieces of information here and saying, hey, I want you to convert this value to this base and then give it back to me. Once you've solved that, hand me the answer because I'm going to do some other stuff with it. That's the problem we're choosing to solve here as the programmer. We're saying the tool we're inventing ultimately has an output. I put 2 things in, it throws me 1 thing back. Go to a bubblegum machine. You put a quarter in, you twist the thing, it hands you a gumball. You know, now you can do whatever you want with that gumball. You can throw it in your mouth and chew it. You can throw it away. You can throw it at some kid. You can do whatever you want with the gumball. The point is that the gumball machine handed you the result. It returned the result to you, which was a gumball. That makes sense? You know, whereas, you know, another thing, maybe you go to the ATM drop off or something like that. You know, you put 10 bucks in there, that's your input, and it gave you nothing in return. It's in your bank account, presumably. Usually they probably would return a receipt or something, but let's just use in this example, let's assume it gave you nothing back. I gave it 10 bucks. I'm trusting that it did the right stuff with my 10 bucks, but it didn't actually give me a result back. So I have nothing to do with that value, and that's okay. It solved the problem I expected it to do, but it didn't return a value because that wasn't the function of that tool. Go ahead. Well, yeah, I mean, here I chose to do something with it. Here I chose to store it inside of a variable, and then I printed it out. So decimal to base, this guy right here, I passed it 2 inputs. You know, think about this like your gumball machine, but instead of putting a single quarter in, I gave it 2 different values. Then it spit back out my gumball, spit back out my answer. I stored it inside this variable answer that's capable of holding a string. And that happens to be the kind of value that decimal to base returns as a string. So I stored the result, and then I chose to prove that I got the right answer out by going ahead and printing out what was inside that variable. Okay, and now I can print it out 50 times in a row if I want, because I've remembered it. I've stored it inside of a little, you know, container. I'm going to save that gumball for later. You know, I'll chew it this afternoon or something like that. But there's a known algorithm for doing it. Where if you just follow the algorithm over and over again, I mean, I think there's only like 3 moves.
No, it's wrong. That's wrong. It depends on what method, you know.
Okay. Well, I don't know either, but I've watched, like, you know, documentaries on it, because, you know, because there's like competitions. There's a thing on Netflix where there's, you know, this, yeah, where, I mean, these people solve a jumbled up Rubik's Cube in like 4 seconds and something. It's ridiculous. And you got those people who juggle. He's juggling 4 Rubik's cubes, and at the end they're all solved. Like, are you kidding me? Yeah. Mm-mm. What's the premise? Be solved in that number of moves or something? Solved in exactly number of moves, or that number of moves or less? Okay. Unless you're doing it, the Mike Littman way, where we just randomly twist stuff until. Yeah. Yeah. I think the short answer is I think I probably would be pretty good at solving a Rubik's Cube, but under the same premise as I should be good at chess, just the way my mind works, but I'm too lazy to think about chess. Like I have the right mental aptitude or whatever, I think, to be very good at chess. But man, that is a boring game. Although, but I mean, I like watching movies about it. Like, was it on Netflix? The Queen's Gambit. That was really good. So, they're making movies about everything. Like I don't know, chess isn't a sport, but competitive things. You would think chess would be kind of boring, but it's interesting enough to not be boring. Now we have like right now there's like world like cheating, competitive cheating going on with chess. The guy who's like the reigning, I don't know, chess czar or whatever, the world champion guy, keeps backing out of tournaments because this other dude goes into the tournaments and he's admitted to cheating or something. I'm using some kind of computerized thing, similar to people who like, count cards at casinos, I think, using some sort of device that helps them do something. I mean, I think that probably has its own interesting skill too, but apparently, it's just brought shame upon the world of chess. There's espionage and so anything to make a buck, although that was a good show, Queen's Gambit. Oh no, another good show that's on there right now is which is potentially disturbing, but I'll premise it. But there's a thing about it's like a docu-series about Jeffrey Dahmer. And that's before most of your time, but that's something that happened in Milwaukee. Kind of a famous serial killer in Milwaukee. But it's really well done, the documentary. It sounds like some of their victims aren't overly happy, the victims' families and stuff. But yeah, if you've never heard of the guy, it's kind of put Milwaukee on the map. But he ate people. is what he killed people and ate people. Is what he. Yeah, he's pretty messed up, and he was killed in prison ultimately. Which, I mean, if the criminals are killing you, you've done something bad, really bad. But the documentary is that, or the docu-series, it's dramatized. It's actually really well done. When I was a kid, I wrote some report on Jeffrey Dahmer or something like that. So like I remember most of the facts, and this was as it was kind of unfolding. Interesting stuff. Okay. So questions about this whole return a value versus display a value, or just doing something. It's not choose one or the other just because, it's what's the right tool for the job. Does the function I just wrote need to do something and give me the result, or does it just need to do something? Go ahead.
The main reason why it's because like at the end of like a lot of the code, it has like the return 0 thing. Is that just specific? Is that just signified that there's no return?
Well, no, the return 0, it's not at a lot of the code. We've just only seen that at the end of main, because historically main, we learned that all programs begin and end with main, and historically our command line programs, like we've seen in here when I ran it from the terminal, they would have a return value of whether or not everything worked. It would give you like a 0 if everything was fine, or it'd give you a 1 for a certain error code, or a 2 for a different error code. You've probably seen it before in web browsers when you get to a web page that something didn't work, it would give you like a 505 error or something like that. Yeah. So there's like a huge list of HTTP errors. Yeah. Yeah. But there's like a huge list of numeric HTTP protocol errors. So those numbers could be meaningful. If it was 404, it means this. If it was 515, it means this, that kind of stuff. So historically, programs that we maybe wrote that were running from the command line, we might choose to have that value that gets returned be meaningful. If you wanted me to write to a file and that file didn't exist, maybe I give you a return code of 8, and that means file didn't exist, something like that. But generally speaking, since we're not really writing programs that give a result like that, we've just been, main typically returns an int for those historical purposes. And we've just been throwing a return 0 at the end because everything's fine, but it's going to yell at me if I don't return a value. Although I don't think C++ does yell at you if you don't return a value. So we really could have left it off. Yeah. But Java and C# would scream at you if you advertise that, hey, expect me to return an int, but then never actually return something. More modern languages are not going to be happy with that. They're going to say, look, you told me you were going to return an integer and then you didn't do it. All right. So you can decide if you want main to return an int or make it return void. For us, I can't imagine a scenario where we're going to have main actually return a value. Or just a historical leftover type thing. So like I was mentioning to him, maybe ignore the whole return thing with main and kind of separate that logic from when we're creating these tools, should we return a value or not? And it depends on the problem we're solving. Does it make sense for us to return a value? If you walked up to a gumball machine and you gave it a quarter and then pushed the button or twisted the thing, whatever, and a gumball didn't come out, you'd be unhappy. It didn't give you a value and you were expecting that value. You were expecting it to return a gumball to you, right? Okay, so if you were the manufacturer of that gumball machine, you're not doing your job very well. Okay, you made a machine that could take the quarter, but couldn't spit the gumball back out. So in that particular case, if we're creating the tool of a gumball machine, we would return a gumball given the input of a quarter. All right, make some sense? All right. Now, we were talking about indexof here. So I mentioned what indexof does is it takes in a string and a character we're going to look for in that string, and it's going to return for us the position in that string, the zero index based position where that character was first found. So it first found an H at bucket 0. It first found an E at bucket 1. It first found an O at bucket 4. Just to give you one more example here. If I search for an L, there's actually 2 L's in here. It first found an L 0, 1, 2 at bucket 2. Even though there's an L at both 2 and 3, it returned the place where it first found the L. That's what this tool does. Okay. And we're about to invent the tool. So we're kind of setting up the rules. Like, okay, I'm gonna build this little machine that if I give it these 2 things, this is the result it'll give me. And we're gonna write the logic for it to do that. All right, make some sense? Then we're starting to work on our algorithm here. So indexof, we'll say it takes 2 parameters. Just takes a string and a char as parameters. So we're going to loop through every character inside that string. So maybe this is a for loop. So let's go ahead and write this. Just that part. We're not solving the whole problem yet. We're just solving a piece of our recipe. Okay. So we're going to write a function here. And ultimately, this is going to return an int because it's going to give us the index 0, 1, 2, whatever, or -1 if it wasn't found. So the kind of type that we expect this guy to return is an int. This will be called int indexof, or if you want to use a capital O for the this, I think I mentioned this last time, it's something called camel case. Usually functions or methods start with a lowercase letter and then use some uppercase letters along the way to spell out what the guy does. This is naming convention, not a law. If you wanted to make your entire function name all caps, that's allowed. Okay, this is more of common naming convention, like we did decimal to binary here with the T and the B capitalized. That's just common naming convention. So index of is going to take in a string and a character we're searching for. All right. And if we wanted to give these more interesting names, we can call this string, source string, and char, lookup char, or something like that. But we'll keep it relatively simple here. So that's the function we're writing. We'll come down here. So we prototyped it. We're going to actually write it down here. All right. And we decided the very first thing we need to do is we need to loop through every character in the string. So we're going to go ahead and do that. How many characters are in this string? Now, how do you know? How do you know how many characters? How do we ask how many characters in there? Yeah, the length. Yeah, s.length is the number of characters that are in S. Okay, this goes back to what we were talking about before about we write it generically. Make sense? Okay, so we're writing this to operate on any string that's passed in and any char that's passed in. Somebody or a bunch of somebodies are going to use our tool and they're going to pass us presumably a whole bunch of different strings. So how do we know how many characters there are in this particular string? It's s.length. There are s.length number of characters in S. So that will boil down to the number of characters in the string that was passed in, whatever that value is. Make sense? All right. So we want to write a loop around this. We want to go through every single character in that string and then ask some questions probably. But right now our recipe is telling us, let's loop through every character in the string. So we'll say for int I is equal to 0, I is less than s.length, I++. Remind me, what does I++ do? And ultimately changes the value of I. Okay, what's the difference if the plus plus comes after the I versus the plus plus coming before the I? Trivia knowledge, talked about it a lot.
Plus before, the plus before like run that first, because it gets added onto it versus the plus after gets added, like after.
Yeah, so if we happen to try to use this value at the same time as we're using the plus plus on the same line, okay, if we're trying to use it at the same time as we're changing it, which may be bad programming practice, then it does make a difference. If the plus plus is before, we get the updated value of it because it increments it before returning the result. If the plus plus is after, we would get the current value of I to use now, and then it would update after we get that value. But we never have to worry about that if we always have this guy standalone. So I++, when this is done executing, I is 1 bigger than it used to be. And because we're not using the value instantaneously there, doesn't matter whether we did ++ I or I++. In either case, when we're done with that, it's 1 bigger. Okay, so this is going to take I on a voyage between 0 and the length of S minus 1, which happens to be the legal characters in S, right? And for right now, we can do something like C out S at bucket I, just to prove that it's working. Okay, so we're going to loop through every character inside of our string. Let's just test this real quick. Dump all this stuff. So we're going to go ahead and we're going to call index of, and we'll pass this guy hello, and we'll pass it an L. We're not even using that L yet, but the expectation here is we're going to get HELLO on the screen because that's what our function currently does. It loops through every character in whatever string was passed in. The string that's being passed in this case is hello. So hello will come in for this string S, L will come in for this char C, and we're going to go through every character in S and just spit out the char to the screen. So this will be HELLO. LC. I told you earlier, must return an int, but we don't actually have to return it. C++ is cool with that. So there's our HELLO. So notice it's giving us a warning that you didn't give a return statement. Still ran, but that's why traditionally we say everything worked fine. When main ended, we returned to 0 saying, if you care, things worked. 0 typically means we didn't have a problem. Okay. So right now we're spitting out all of the characters in the string. So we have fulfilled the first part of our algorithm. Loop through every character in our string. Okay. Next part of our algorithm is ask the question whether the current character we are looking at is the character we are looking for. Right? How do we do that? Probably an if statement. So we need to ask a question. So we're going to ask the question down here. We see this is the way we get the current character. So we're going to say if the current character that we're interested in, the current character we're looking at, if that guy is equivalent to the character we were looking for, if I found that character, what do I want to do? What is indexof supposed to do? Does it return the character? Location. So indexof takes a string and a character, and it returns the index, the int-based position in that string where it first found that character, or a -1 if it never found it. So as I'm going through the string from the beginning towards the end, each time through, I'm asking the question, is the current character I'm looking at equal to the character I'm looking for? If it is, I need to return the position in the string where I found it. And what's the position in the string where I found this character? Well, S at bucket I is what? What kind of animal is this? That's the character. That's a char. I is the actual location in the string where I found that char. Remember, I goes on a voyage in here between 0 and the length of the string -1. So I will be 0, 1, 2, 3, 4, blah, 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 blah. All right. So if at bucket 3, I found the character I'm looking for. If when I looked in the string at position 3, I found the character I was looking for, I'll return the 3. That's where I found it. Make sense? Lastly, what happens if I never found it? What happens if I looked everywhere in the string and I didn't find it? What should I do? Yep. So if I never find it, return a -1. After the for loop, if I am still alive, I'm going to throw an extra slide in right here with the return statement. So we have a keyword here called return. So return is the tool we use to return a value from a function. Return itself, well, return actually makes a function immediately end and optionally can return a value. So we don't have to use a return statement. Well, we don't have to be inside of a function that returns a value to use a return statement. Let's say I'm in a function and that particular function, I need to make it end earlier. Something's gone south. It's not doing what it needs to do. I'm not supposed to return a value, but I'm not going to waste my time asking any more questions. You can just say return semicolon, and that function will end. Only if you put a value after the return statement does it try to spit that value out. All right, so return could even be used, just as an example here. Here's the void function here. For no good reason, I can throw return there at the end. I can't return a value because I have advertised that this function doesn't return anything. I can't return a value, but I can certainly say, hey, look, I know you're about to end anyways, right here, when we hit the end of this function, but I like to kind of control the narrative. So I'm going to make you end one line sooner. And by the way, that line didn't even exist before until I said you stop now. Okay, so the thing to keep in your mind related to this is return is a tool that can make a function immediately end. Sometimes that's something you're going to want to do, even in functions that don't return a value. And we'll see examples of that, but this is just something to keep in your mind for right now. All right. So if we never find the character, we're going to return a -1. So after the for loop, if we're still alive, a lot of times I'll think of loops like this. Where's my index? I'll think of loops like this. It's kind of like a minefield. Okay. If I'm still alive after this guy, I'm going to return a -1. Remember that return right here. If I hit that return statement, this function just ended. So if I found the character I was looking for at position 3, when I return 3, I'm not looping anymore. This function just died and spit a 3 out. Make sense? So I will never get to this line if I happen to hit that line. This return makes a function immediately end. Okay. So if I'm still alive when I get down here, that means I've checked everywhere in that string. And I never found a condition when that if statement's true. Because we would have only executed this line if this if statement was true. All right, make some sense? All right. So now we can test these. I wonder what it'll look like if I just try to copy and paste from here. What's it going to do with those dealies? Yeah. Could have been worse. What's the output of this program going to be? Actually is it is bad because right now those are all cut and paste. This is actually a common mistake. So if you find code on the internet or something and you copy it, you paste it in your program. Yes, these are double quotes, but it's a different ASCII value. It's not the same double quote. Are you serious? It's not the same double quote as that. So I could do something like this, where I steal the real one. Can I replace it with something? That's what I thought I did. Oh, I see what you're saying. I can just do that. Which is perfectly, that's exactly what I wanted. That is totally exactly what I wanted to do. Oh, this is actually I need to do the, oh, it did work. Okay, there we go. And I'm guessing we also have the problem there for the single quotes. Stupid. Oh. Punchline is it's gonna let me just do that. There we go. All right. Yeah, I guess the copy and paste really did not help me at all here, really, because I had these arrows. It's stuff. Right. And we'll go ahead and see out these guys. So there's our 0, 1, 4, 2, -1, which is the thing we were expecting. 0, 1, 4, 2, -1. All right, make some sense. All right, so I'm going to save this, then I'm going to hit share just to give you a starting point. Yeah, this may or may not be helpful for your homework content. All right, so homework. Write a function that takes a string representation of a number and the base that number is in, and returns the decimal equivalent of that number. So this is base 2 decimal. Right, base to decimal, it takes a number, it takes a string representation of a number and the base of that number and returns the decimal equivalent. So for example, base 2 decimal, if I pass it 101, and I say this is in binary, this guy should give me the decimal equivalent. This is the 1's place, the 2's place, the 4's place, so this is a 5. Base 2 decimal, BAD, and I say it's in base 16. This guy should give me 2989. So this is the other pattern. Homework for today was to write decimal to hex, and then in class we saw decimal to base. Now we're going to write the generic function that will go from some base back to the decimal equivalent. Make sense? So given this guy, do all that, submit a link to your code and the self-assessment. And that will be due on Tuesday. Questions, comments, concerns, bribes? All right, I'll see everybody on Tuesday.